Hello everyone, welcome to another video on integration, and today I'm going to be looking at integration by parts. And this is a formula for integration by parts. So in other words, if you're given an integral, the task is to identify u and dv. And if you can identify u and dv, then this formula applies, where u has to be differentiated and dv has to be integrated. So in integration by parts, we employ both integration and differentiation. Right, so let's look at the first example then. Here is the first example. Integrate the integral of x e to the power x dx. So that's our integral that we have to integrate. So how do we go about this? Here is the approach. Let me capture the question first. Our answer or solution is set out as follows. Our first integral is we're supposed to integrate this integral here, x e to the power x dx. Remember, I told you the formula is supposed to be u dv is equal to uv minus v du. So in this case here, we look at the two expressions forming the integrand, the two expressions, which one is easier to differentiate and which one is easier to integrate. So I'm going to take u to be equal to x because it's easier to differentiate x. So I'm going to say let u be equal to x, and at the same time dv equals e to the power x dx. So I'm going to differentiate with respect to x. You can agree with me from the previous video that this is just du dx. Du equals dx. And on the other side, if you integrate both sides, you're going to see that the integral of dv obviously is v, and the integral of e to the x is just e to the x. Right. Now going into the formula, the formula says the integral of u dv equals uv minus v du. Now notice that this one here is exactly x e to the power x dx. This is u dv is equal to uv. It's going to be this multiplying by that, so it's x e to the power x minus v du. Where is our v? Here it is, e to the power x. Du is dx. You can see it from there. And what is the integral of e to the x? I've shown you in the previous videos that this is just e to the x. So x e to the x minus e to the x. And obviously we're dealing with what we call indefinite integral, so we have to add a constant at the end. So this is the solution. Now, quite easy and straightforward. For this formula applied once, watch what happens when the power of x is 1. This formula is applied once. What happens when the power of x is 2? You still have e to the power x dx. What happens? We're going to look at that in example number 3, but I want to look at a more difficult case of a single application of u dv equals uv minus v du. A single application, but a little bit more complex. So let's look at question number 2 then, which is a little bit involving, like I've said. Here is question number 2. Take a look at this. Take a look at this. Where do you start from here? Not looking very friendly. But remember, I've shown you in the previous videos that when you have a plus or minus there, the first thing you need to try is what we call term-wise division, where the denominator divides into each of the terms there, of course respecting the sign there, whether it's plus or minus. So we start with term-wise division in this one. So our solution for number 2 is set out as follows. So we have the integral of 1 minus x, the natural log of x, all over x e to the power x dx. And using term-wise division, like I told you, this is going to be 1 over, if you like, let me use brackets here, x e to the x, and then we respect that minus sign there, we're going to say minus x natural log of x all over x e to the power x, and we are saying dx. you can clearly see that this x cancels here. And if I take this term up, the e to the x up and the e to the x up, I'm going to have here, this is going to be the integral of, check this out, e to the power minus x times 1 over x dx, distributing dx of course, minus, check this part here, it's going to be e to the power minus x natural log of x, the integral of that dx. Right, so this is where we're at. Now, let's start by working on this one here first. So if you look at this one here, we can now apply integration by parts because this is easy to differentiate and that one is also easy to integrate. So we're going to say, using this one here, we're going to say let u be equal to e to the power minus x. At the same time, let dv be equal to 1 over x dx. Now, differentiating u with respect to x, you'll agree with me that this is actually du dx equals minus e to the minus x. So I can just take the dx on the other side. I'm going to have minus e to the minus x dx, like so. Now, and obviously, if you integrate both sides here, you're going to find v equals the natural log of x. We've shown you a couple of times that this is what you get. Right, let's go to our formula now. What does it say? It says u dv, the integral of that, equals uv minus the integral of v du. Remember, we're focusing on this integral here. And so what is this? Well, this is the integral of, what is u? E to the minus x. What is dv? 1 over x dx. This is equal to, what is u? E to the minus x. What is v? The natural log of x. There it is. Minus, we're here now, the integral of, what is v? V is the natural log of x. What is du? Is minus e to the minus x dx. So what I have now is, open brackets here, minus e to the minus x. That's my u. Remember, it says v du. So du, this part here, is equal to that part. So, but now I have v also. Remember v du, and I'm combining v du. So I'm combining this and that. I'm combining this expression and that expression there. So I must have this, and then what else must I have? I must have v, which is natural log of x, and then there, what do I have? Dx. Remember, there's your dx. Let me use, let me close the bracket there. Now, let's work on this integral here, this integral. This part here, it's fine. Let me get to the next page because I don't have enough space there. Let me get to the next page here. I think you can see the calculation from there. Yes, you can. Right, so now I'm going to say, if I stretch backwards a little bit, I'm going to say that is equal to e to the minus x, the natural log of x, like so. And then expanding this, removing that bracket there, this minus and that minus will give us a plus sign, the integral of e to the minus x. Take note of that, the natural log of x dx. So this here is actually for only that first part of the integral. So I'm going to say, let me move it down so you're able to see what I mean. This solution here is for only this part, but we still have minus that. So we're going to say here, finally, we're going to say, therefore, the integral of 1 minus x, the natural log of x, all over x e to the x dx, this one must be equal to, notice now I'm taking everything. The first part, like I said, first part is this part here, and I want to capture the expression for that, and then I'm going to say minus this. So what is the expression for that? Well, here it is. So it's e to the minus x, natural log of x, plus the integral of e to the minus x, natural log of x dx, minus, take note, minus this part here, which again is the integral of e to the minus x natural log of x dx. So the integral of e to the minus x natural log of x dx. And clearly you can see that this cancels that. And so my final solution then is going to be e to the minus x, the natural log of x, like so. And then I have to say plus c because I'm dealing with indefinite integrals. So again, a little bit more challenging this one, but u dv equals uv minus v du, this formula, which is the formula for integration by parts, is applied only once. If you notice, it only applied here. And then we obtain an expression, and then when we plug into that space there, this one is cancelled, and so we remain with that expression. I want to challenge you to differentiate this by using the product rule. Differentiate this by using the product rule. You must get this one here as your final solution, this one. Why? Because the inverse operation of differentiation is integration. Right, so that is our number 2. Let's move to number 3. For the sake of time, otherwise I would have differentiated that and shown you that indeed it produces that, but please go through that and let's see what you get. Put some comments in the comment section below, and then we'll see if you agree with what I'm saying. Let's look at number 3. We have number 3 here. It says integrate x squared e to the power x dx. Let me take you to the first integral. Here it is. I told you that when there is x to the power 1 here, the integration by parts formula is applied only once. Let's see what happens when the power is 2. How many times do we apply integration by parts formula when the power is 2? So let's capture this then on a fresh page. So number 3, we have the integral of x squared e to the power x dx. Using integration by parts, it's easier to differentiate this, because at least when you differentiate once, differentiate a quadratic function or expression, you get a linear one, and then you can maybe differentiate that one again, and then you are going to get a constant. So let's look at the next step. We let u be equal to x squared, and at the same time we let dv be equal to e to the power x dx. Integrating both sides, we get v equals e to the power x. Differentiating both sides, or differentiating u with respect to x, you're going to get du equals 2x dx, if you see what I mean. Now, the formula for integration by parts, u dv is equal to uv minus v du. Right, so we're going to say, therefore, that expression, this integral, we have the integral of x squared, the e to the power x. My hand misbehaved there. Let me remove it quickly. We have x squared e to the power x. I'm basically recapturing this integral here. Dx, I'll come back and fix that, is equal to uv. What is u? X squared. What is v? E to the power x. And then minus v e to the power x du. It's 2x dx. 2x dx. Notice that. Now, if I rewrite this part here and taking the 2 out because it's a constant, I'm going to have x squared e to the power x minus 2, the integral of x e to the power x dx. If you remember in the first question, we actually integrated that. But I want to do it again because repetition is critical in the process of learning and teaching of mathematical sciences. Right, so let's look at this part. Now I'm going to take this part here to be equal to I for integral. If we had I1 equals that, this would be I2, but I've decided to just call this one I. So we're going to say, what is our I? Our I is going to be the integral of x e to the power x dx. Now notice that here we can apply integration by parts again. We let u be equal to x, and dx dv equals e to the power x dx. Integrate, differentiate with respect to x, you're going to get du equals dx. Integrate both sides, you're going to get v equals e to the power x into the formula u dv is equal to uv minus v du. What is u? Well, u is x. What is v? E to the power x minus the integral of what is v? E power x du. What is du? dx. Of course, you can see that this part here simply gives us minus e to the power x. So now, in that place where I put I there, I must replace this integral with this one here. So I'm going to take this into that space, and of course respecting minus 2 outside there, and then simplify. So let me just fix this before I forget. That's x squared, remember, e to the power x, e to the power x dx. Right, now let's come back here. So now we're going to say, I think this should be enough space. Now we're going to say, therefore, our integral, which one? An integral x squared e to the power x dx must just be equal to, where am I at? I'm here. This part, x squared e to the x minus 2, x squared e to the x minus 2, and I'm going to say open brackets here. In the place of that, I'm going to put x e power x minus e power x. So x e to the power x minus e to the power x. And now I must say plus c because we're dealing with indefinite integrals. Simplifying this, what do we get? We get x squared e to the power x minus 2x e to the power x. Notice the 2, the minus will cancel that minus, and so now I must have 2 e to the power x plus c. That's my final solution to which integral? To this integral here. Now, the case of interest is the fact that when the power of x is 2 is 1, you apply this formula once. When the power is 2, you apply it twice. You can see it here, you can also see it here. When the power is 3, you'll have to apply 3 times, and when the power is n there, obviously you have to apply it n times. So I'm going to leave it to you, the generalization of it, but otherwise that's the approach. Now let's look at the last one, question number 4. Number 4, we're still dealing with integration by parts. Number 4 is this one. There is number 4. We're supposed to integrate x plus 5 in brackets, open brackets, x minus 3 to the power 5 dx. Now, notice expanding this and then expanding that and that together. It's tedious. So what do? We apply integration by parts. I'm going to let u be equal to this because it's easier to differentiate that, and I'm going to let v dv be equal to x minus 3 power 5 dx. Remember the formula for integration by parts requires us to identify u and dv. So let's look at the solution for number 4. We have the integral of x plus 5, multiply this by x minus 3 power 5 dx. So what am I saying? I'm saying we let u be equal to x plus 5 and dv be equal to x minus 3 or 5 dx. Now, what do we get on this part? You differentiate both sides, you can see that you're going to get du equals dx. Because derivative of u with respect to x, du dx will be equal to 1 here because derivative of x is 1, derivative of 5 is 0 because 5 is a constant. So du dx equals 1, it means du equals dx. And integrating both sides, remember the coefficient of x there is 1. If it were 2, I'm going to tell you what you need. If it's 2, I'm going to tell you what you need to do. But in this case, it's 1. So when you integrate both sides, you're going to get v equals, this will be x minus 3 power 6. Remember, all over 6. You add 1 and then divide the answer you obtain. Add 1 to the power, and then whatever you get, divide in the expression. Now, if I had a 2 there, I would have divided by 2 again. So it would have been 2x minus 3 power 6 all over 2 times 6, which would be 12. Please check by using integration by parts. No, not integration by parts. Check by using u substitution to see that that is correct. Let me check my time there at 19 minutes. So if I have sufficient time, I want to do this within 25 minutes. If I have sufficient time, I'll come back here and show you that indeed if there's a 2 here, down here you must have a 12, and the power obviously is still going to be 6. Right, but let's carry on for now. So you're going to say in the formula now, u dv is equal to uv minus v du. That's integration by parts formula. Now what is this? Well, it's this one here, x plus 5, that's u. What is dv? It's x minus 3 the power 5 dx. That's dv. This must be equal to, what is u? Where u is x plus 5. There it is, that's u. And v, what is v? There it is. It's x minus 3 power 6 all over 6 minus v du, where v is this expression here, which is x minus 3 power 6 over 6. That's v, and du equals dx. Now integrating this part, you can see here that you're going to add 1, you get 7, and then you must come and divide. So 7 times 6, it will be 42. So then if I move backwards a little bit, I'm going to say the solution is 1 over 6. Obviously 6 is dividing. Then we have x plus 5, and then we have x minus 3 power 6, and then we are going to have minus, remember, x minus 3 power 7 all over 6 times 7, because 7 has to divide also, plus a constant. Let me simplify this. So my final solution then is going to be 1 over 6 x plus 5, and then we have x minus 3 power 6 minus, and this is going to be x minus 3 the power 7 all over 42, and then plus c as a constant. So this is the final solution. This is the final solution. Now I'm looking at the time there. I have just under 22 minutes. Let me come back to this part here. I was showing you that if I had integration of this, if there was 2x minus 3 to the power 5, you are required to integrate that. Let me just show you that quickly, if I may. So we are saying the integral of 2x minus 3 to the power 5 dx. What I was telling you is, if you say let u be equal to 2x minus 3, notice du here is going to be 2 dx, because derivative of u with respect to x is going to be 2. This is out because derivative of constant is 0, and therefore you multiply both sides by dx, you're going to get this. Now coming back there, this would be the integral of, notice now it will be u to the power 5 times dx. What is dx? Make dx subject to formula here. You're going to get dx is actually equal to du over 2 if you divide there. So here I'm going to say du over 2. Remember, in the place of dx, I must put du over 2. Now, what is this? 2 is a constant. Take it out. The integral of u power 5 du. What is the integral of u power 5? Is actually u power 6 over 6, what I told you. And if you simplify this, obviously you're going to get 1 over 12 u power 6. What is u power 6? What is actually u? Because we're dealing with u power 6 here now. What is u? Well, u is 2x minus 3. So this would be 1 over 12, 2x minus 3 to the power 6. So this is what I was saying earlier on, that in here, when the coefficient of x there is 2, whatever you do here, you must remember to also divide that coefficient of x down there. So this would have been 2 times 6, and that would be the solution there. Right, but now here we didn't have that, thank goodness. Right, so in this video I'm going to stop here. I decided to bring in integration by parts because I was requested by one of my students to say, please, would you touch on integration by parts? So I've done that, but I will still be coming in with more questions involving, like I promised, use substitution, integration by parts. I also want to look at integration of exponential and logarithmic functions, and then we'll also look at partial fractions, and we'll end up with trig functions, application of trigonometrical functions in integration. All right, if you're new, please support us by subscribing, inviting friends to subscribe, sharing these videos, and we appreciate your support. All right, God bless. See you next time.